Hello, everybody. Welcome to this webinar today. I'm glad to have you. I'm going to kick things off. First up, I'd like to say that even as we're meeting digitally like this over Zoom, it's important to remember that many of us are joining from somewhere in the Ottawa River watershed, which is, of course, the unceded and unsurrendered territory of the Anishinaabe Algonquin people. Ottawa Riverkeeper's offices are located on this territory, and almost all of our work takes place on this territory. So we make sure to acknowledge that at events like these and whenever we're doing our work around the watershed. Je veux aussi dire que le webinaire aujourd'hui se déroulera principalement en anglais, mais nous sommes un organisme bilingue, donc vous pouvez poser des questions en français et de plus, la plupart ou peut-être la totalité de ce que nous couvrons aujourd'hui est maintenant ou sera bientôt disponible sur notre site web dans les deux langues. Speaking of questions, if you do have questions, please toss them in the Q&A panel that you'll see at the bottom of your Zoom window. We'll be monitoring them throughout, and then I'll hop back in at the end of the presentation to ask them to our panelists. But who am I? I'm Matthew Brocklers. I'm Communications Manager here at Ottawa Riverkeeper, and I'm joined by my colleague Larissa Holman, our Director of Science and Policy. And we're also really pleased to have today with us Chelsea Lobson of the Lake Winnipeg Foundation, who'll be diving into the topic of phosphorus for us all. I'd also like to say that we'd like to thank the Canada Water Agency for providing funding to run this event and some of the other events that we've been doing recently. Before we jump into today's main topic, allow me to do a little bit of promotion for Ottawa Riverkeeper. If you don't already know who we are, Ottawa Riverkeeper is a charity and nonprofit organization focused on the health of the Ottawa River and its tributaries. If you'd like to follow along with our work, the best way to do so is to sign up for our newsletter. We send one out about once every 2 weeks with tons of information about our programs, what's going on in the watershed, ways you can get involved, etc. I'll toss a link to that, how to sign up in the chat. And if you'd like to, you can also follow us on social media on Facebook, Instagram, LinkedIn, and tons of other platforms.
Awesome. Thank you so much, Matthew. I'm just going to jump in quickly to introduce Chelsea more thoroughly, but also just to give a little bit of a preview about why it is that Ottawa Riverkeeper reached out to Lake Winnipeg Foundation to talk about phosphorus. Our watersheds are not close to each other. We do not influence each other's, but when we first started doing our total phosphorus monitoring program, we actually reached out to Lake Winnipeg Foundation, and Chelsea and I and my colleagues had a conversation about their monitoring program because they've had a total phosphorus monitoring program that has been really influential. And they were incredibly generous in sharing what they did, how they worked with their community scientists, and how they analyzed the work. So I do want to really highlight that there's a lot of collaboration that happens in Canada amongst watershed organizations. And this is a great example of how that collaboration leads to actual work getting done in different watersheds. So and why did we reach out to Chelsea? Well, Chelsea is the program director of the Lake Winnipeg Foundation. She has a master's of science from the University of Manitoba and experience in freshwater ecology and working on large collaborative projects. I'm going to hand it over to Chelsea to introduce the program from the Lake Winnipeg Foundation more fully, and hopefully folks from the Ottawa River watershed can learn a little bit more about one of the Great Lakes.
Awesome. Thank you so much. I'm just going to share my screen here. Give me a moment. Okay. You can see that okay? Okay, great. So thank you everyone for joining today. My name is Chelsea. I work at the Lake Winnipeg Foundation, and the Lake Winnipeg Foundation is an environmental charity that works to restore and protect the health of Lake Winnipeg. And I first wanted to acknowledge, do a land acknowledgement for Lake Winnipeg as well. So Lake Winnipeg, the lake that we at the Lake Winnipeg Foundation are working to protect, is a part of the traditional territories of the Innuak, Anishinaabe, Nakota, and Dakota peoples, and the homeland of the Red River Métis. and Indigenous people have cared for Lake Winnipeg since time immemorial. So today I'm going to be talking about the Lake Winnipeg Community-Based Monitoring Network, which is a network of citizen scientists and watershed partners working together to collect water samples for phosphorus testing. And this is a program that began in 2016, so we've just launched our 10th field season, which is really exciting. But we still have a lot to learn about new ways that we can engage volunteers and share our data. So I'm really looking forward to hearing the Ottawa River Keeper side of this presentation and learn from you folks as well. Okay, so a little bit of background on Lake Winnipeg. Lake Winnipeg is the 10th largest freshwater lake in the world, and it sustains biodiversity, economies, and culture around the lake. It's especially known for its beautiful beaches. If you've ever had the opportunity to go to Grand Beach or Victoria Beach around Lake Winnipeg, it's a beautiful spot, and it's a jewel of the province. Unfortunately, though, Lake Winnipeg is sick. Over the last few decades, there has been a decline in the health of Lake Winnipeg, and especially with the increase in the frequency, severity, and extent of potentially harmful algal blooms on the lake. So you can see a photo here of one of those beautiful beaches that I was mentioning. This is a photo of Victoria Beach, and you can imagine a family with kids or pets coming out to the beach for the day and seeing this thick mat of green algae that could be potentially toxic and harmful, and obviously not something that you want to swim in or fish from. So this is a real challenge here facing Manitoba. Luckily, though, we know from whole decades of whole ecosystem science from the experimental lakes area that phosphorus is the cause of these algal blooms. And so if we want to reduce the impact of these algal blooms, we need to reduce the phosphorus load entering the lake. But in order to reduce the phosphorus entering the lake, we need to know where the phosphorus is coming from in the watershed, and that's where our program comes in. So as you can see from this map that I showed earlier, the watershed that flows into Lake Winnipeg is huge. I think a lot of the Great Lakes have a watershed that have about a 1-to-1 ratio of lake to watershed. But Lake Winnipeg's watershed is about 1 million square kilometers. It spans 4 provinces, dips into 4 US states. And when we look at the map of the watershed like this, the challenges facing Lake Winnipeg can seem insurmountable, especially as people in Manitoba who get to enjoy the lake. Worrying about what they're doing in these other jurisdictions can make the challenge feel kind of out of our control and can lead to a lot of finger pointing to other places instead of focusing on what we can do to improve the health of the lake. And even though the watershed is huge, and everything happening in the watershed can have an impact on the lake, not all areas of the watershed are contributing the same amount of phosphorus. So if we can identify the areas that are contributing more phosphorus on average, we call those phosphorus hotspots. Then we can begin to target resources and action to those hotspots to have an impact on the lake. And suddenly this major overwhelming challenge is broken down to a to-do list of areas that need to be focused on and addressed. So this is another map of the watershed, this time broken down by the major tributaries to Lake Winnipeg. So for example, this is the Red River watershed. This is the Canada-US border here, Lake Winnipeg. This is the Red River watershed, the Assiniboine River watershed, the Winnipeg River watershed, which goes into Ontario. And then this is the Saskatchewan River watershed here. And this is about the level of data that's shared in the State of Lake Winnipeg report, which is a report released by the provincial and federal governments. And from this data, we have a really good idea of the major contributors of phosphorus to the lake. So for example, we know that together, the Red and Assiniboine rivers contribute about 70% of the total phosphorus load to Lake Winnipeg. So that's a great place to start if we want to begin to address phosphorus loading, but that's still a massive area with a lot of different topography, land use, soil type. And so ideally we would have higher resolution data in order to more accurately identify these hotspots. And that's exactly what the Lake Winnipeg Community-Based Monitoring Network does. It samples at many of the smaller tributaries, complementing the provincially and federally collected data by breaking down these larger watersheds into smaller pieces to help us identify hotspots at a finer resolution. And this is an example of data from one of our sites. So this is South Tobacco Creek near Miami, Manitoba, of course. This is in south central Manitoba. And the blue line on the bottom here is water flow. And then the black dots are measured phosphorus concentration from samples collected by a volunteer. And as you can see here, when the flow increases, and this is during the spring snowmelt period. So in Manitoba and on the prairies, the biggest flow event is typically during the snowmelt period because snow accumulates all winter and then it flushes with it all of that water in the spring once things melt. But that's also when we see the greatest concentrations of phosphorus as well. So this is a really important time to sample if we want to accurately estimate phosphorus loading from these small streams on the prairies. But this can happen in a relatively short window. So in Manitoba, a lot of the more centralized monitoring programs, the government monitoring programs sample based off of a calendar. So they typically sample 4 times a year. And you can imagine that if you sampled 4 times throughout the season, there's a really good chance that you could miss this relatively short peak in concentrations that would lead to an underestimation of the phosphorus load from the site. So having the volunteers and partners on the ground ready to collect a sample in response to these flow events is really what makes this project unique and is what makes us able to collect this high quality data that wouldn't be possible without the volunteers and community partners who live and work and commute in these areas. So as you might have gathered from the last slide, water flow is really important to our program. So whenever possible, we match our sites up with Water Survey of Canada stations. And this helps us in 2 ways. So first, it allows us to monitor the flow in real time online and mobilize volunteers and partners when a runoff event is occurring at their site, when we see the flow increasing, and we can ask them to go collect a sample. But it also helps us afterwards in our data analysis. So we can take the phosphorus concentration and multiply it by the water flow at the site, and that gives us the phosphorus load of a site, which is in tons of phosphorus per year. And then another piece of data that's really important, and I'm going to be talking about a lot, is phosphorus export. So this is kind of like a yield in agriculture, but we take the phosphorus load and divide it by the drainage area that contributes to a sampling site. And this is what we use to identify areas of land that are contributing more phosphorus on average than others, and how we identify phosphorus hotspots. And now I'm done with all the math, I swear. So once samples are collected at a site, they go to the lab where they're analyzed by our field and data technician, Carl, who's in this photo. So we actually work really closely with Dr. Nora Casson at the University of Winnipeg. She's interested in using our data in her research, and so she provides us with lab bench space to run these samples, which has been really great. And in the last couple of years, we have prescribed to this Proficiency Testing Canada, which sends us a set of blank samples with unknown phosphorus concentration. We run the samples and then we submit the data back to Proficiency Testing Canada, and they let us know if we got the concentrations right, basically. So it gives us a lot of confidence in our data. We've always gotten very high grades on these tests, and so I think this is really helpful, especially when we're talking to governments and academics about using our data, just providing that extra layer of trust in in the data that's being generated through the program. So this is a map that shows all of our sampling sites. So green is Water Survey of Canada stations, red is no Water Survey of Canada station. So sometimes we're interested in sampling at a site where there is no Water Survey station. They're not always located in exactly the spot that we're interested in sampling. So those are in red, and then yellow is Water Survey stations that are not flow metered. So some of them have just water level data. But you can see that we have great coverage of southern Manitoba, especially of the Red and Assiniboine River watersheds. So here is an example of data. So our most recently, our data from 2023 came out in early March. And this is a map of phosphorus export from each site. So that's in kilograms per hectare per year. And if a drainage area has higher phosphorus export, then it's more red. If it has lower phosphorus export, then it's more yellow to white. And what you'll notice from 2023 is that there's not a lot of phosphorus hotspots popping up. There's not a lot of red sites where we see these phosphorus hotspots. And this is because 2023 was a dry year. And what we noticed from our data is that dry years have much lower phosphorus loads and exports, and wet years has much higher phosphorus loads and exports. And so we can kind of guess if there's going to be hotspots in a year based off of how the season goes in advance. But despite it being a moderately to severely dry year in 2023, we did see some moderate hotspots pop up that you can see here when we zoom into the Red River Valley. So this is called Roselle Creek, and this is called Rivière au Marais. And this was a relatively dry year. So it's interesting that these areas still had a relatively high phosphorus export, and we'll want to continue tracking these going forward. They were in the Red River Valley, which when we see phosphorus hotspots, they do tend to be in the Red River Valley. So that part of it is as expected. And as you'll notice when you look at our years of data, every year kind of has its own unique story. So for example, when we go back to 2020, it was a dry year. There were some phosphorus hotspots that pop up on the eastern side of the Red River Valley. 2021 was a severe drought in the area, and there was no phosphorus hotspots, really low loading across every site sampled. 2022 was a flood year, and you can see there's much higher phosphorus exports, many phosphorus hotspots popping up, especially in the Red River Valley. And then 2023, which I just presented on, a dry year like 2020, but now phosphorus hotspots on the western side of the Red River Valley. So each year has its own story. It depends on kind of what the localized weather patterns are, what's going on the land. But really, this is a long-term monitoring program, so we need to continue to track these phosphorus hotspots into the future to really understand what's going on. And we need to stay focused on the persistent phosphorus hotspots that have been identified through the network. So this is kind of a messy slide. It has our old style of maps mixed with our new style of maps, but you read them the same. Red means higher phosphorus export and phosphorus hotspot. Later this year, it's on our work plan to get these all updated for our 10th field season into the same format, which will be wonderful. But for now, these are all of the wet years of data. So these are all of the years where we see that high phosphorus loading from the watershed, and we see phosphorus hotspots really popping up in the watersheds that we sampled. So 2016 was when we started, and you'll notice there's a lot of growth over the years in the program, which is great to see. But you'll notice these red hotspots popping up each year in the southeastern side of the Red River Valley. And this is the Seine River watershed. And this is an area that, yes, every wet year comes up as a phosphorus hotspot. So we feel very confident suggesting that resources and action be targeted to these hotspots in order to have an impact on the health of Lake Winnipeg. This is a great watershed to start in when we want to think about reducing phosphorus loads. And just to show we aren't the only group noticing these high phosphorus levels in the southeastern portion of the Red River Valley. So this is data from Agriculture and Agri-Food Canada, and it is their annual phosphorus balance maps. And I think this is available for all the agricultural areas of Canada. But basically, they calculate these maps by adding together the various phosphorus sources from the manure fertilizer sources of phosphorus and synthetic fertilizer sources of phosphorus, and then they subtract the amount of phosphorus removed from crop removal. And the annual phosphorus balance is what's left in the land once the crop has been removed. And so areas with a high phosphorus balance have a higher risk of having phosphorus run off during things like floods or with the snow melt. And as you'll see on this map, so just to orient you, Lake Winnipeg's up here. This is the city of Winnipeg. The Red River comes down. And this is that southeastern portion of the province where we have identified these persistent phosphorus hotspots over the extent of our program. And so definitely like many lines of evidence pointing to these areas being places that we need to focus our efforts. And what's really neat now is that this program's been going on for a while, and now seeing how this data can be used to inform management and policy decisions. So when this program was conceptualized, I guess, the idea was that it could be used by funding programs to target resources. We had funding programs that were being done specifically to reduce phosphorus loading from the watershed. And we noticed that funding was just being sprinkled over this vast area and wasn't being really strategically directed to the areas that needed it most. And that was because there wasn't really data to point people towards the areas that need it most. But now this data exists through the Lake Winnipeg Community-Based Monitoring Network. And one of these programs that we hope can use the data to target their funding is the federal Lake Winnipeg Basin program. So this is one of the freshwater action plans by the Canada Water Agency. And we were very excited when last year, I believe, the federal government committed to implementing a more targeted approach with their funding by March 2027. So the federal government has made this commitment. We have the data to support it, and we're basically sharing everything we can about our program with everyone possible at the federal government lately. So the policy advisors, the program managers, Environment Canada and Agriculture Canada scientists. We had the Director General of Environment Canada in our office just a few weeks ago to talk to her about the data as well. So this is a really exciting thing that's kind of in motion presently. Another cool way that the data is being used is to target research to phosphorus hotspots. So there is a group of researchers at the University of Winnipeg who used our data to target a manure runoff study to a phosphorus hotspot because they wanted to do their research in an area that it would have the greatest impact. And I think that's really great that people that researchers are thinking about how their data will be used and how they can do their studies in a way that facilitates that data use right from the get-go. Our data has also been used to inform and calibrate watershed models that happen in the Lake Winnipeg watershed. So sometimes the government is trying to model phosphorus hotspots, in which case they'll use our data to kind of ground truth what they're finding. And I think it's pretty cool that a community-based monitoring network data set is being used as the truth in a government modeling effort. So when everyone sees a map of our phosphorus hotspots, the obvious, and notices the persistent hotspots, the obvious next question is, well, what's going on in those areas? how can we address the phosphorus loading from those areas? But one of the challenges is that our data tells us where the phosphorus hotspots are located, but not why phosphorus loading and phosphorus exports are so high from those areas. So a next step for us and our program is to combine our phosphorus export data with land use data to try to make connections between what's happening on the land with what's happening in our waterways. So one way we plan to do this is by doing a spatial correlation study. So one of our science advisors, Dr. Greg McCullough, myself, and Carl, the field and data technician, are working on this research study. Right now, we're just in the data gathering phase. So we're trying to get the best available data on different land use practices that can contribute phosphorus. So for example, synthetic fertilizer application, wastewater phosphorus data. And another important piece of data for us is the manure management plan data from Manitoba. So those persistent hotspots that I mentioned on the eastern side of the Red River Valley, that area has the densest livestock agriculture in the province. And so it's really important to us that we include the manure data in our study. From this map, you can see a map of the manure management plans by township. Just to orient you, this is Lake Winnipeg, the city of Winnipeg, and the Red River here. So this is that southeastern portion of the province, and this is where there's the most manure management plans. We did a Freedom of Information request from the province, and we received the amount of manure applied in each of our watersheds, as well as the numbers of livestock by species for each of our watersheds. So this is a really great step, and I don't think any of this data has been incorporated in spatial correlation analyses of the watershed previously. So we're very excited to have this data and to see how it relates to our hotspots. Another important piece of data that's helping us identify sources of phosphorus in the watershed now is our dissolved and particulate phosphorus data. So this was a new thing for us in 2023. And the reason this is interesting is because the different sources of phosphorus can point to, or the different types of phosphorus can point to different sources of phosphorus from the watershed. So for example, dissolved phosphorus is more bioavailable, and it comes from sources like sewage, manure, and fertilizers, where particulate phosphorus is less bioavailable, and it comes from sources like soil erosion. And we also hope that this data is useful to the watershed districts that we work with, which is kind of like I think they are called conservation authorities or something like that in Ontario. Larissa can help me. Anyways, we call them watershed districts, and they do a lot of phosphorus reduction projects on the land. And so different sources of phosphorus require different beneficial management practices. And so hopefully this data is useful to them in targeting the best beneficial management practice to the type of phosphorus that we're seeing. And here's an example of that dissolved phosphorus. So this is the same type of chart as before. Black is total phosphorus concentration, and the green is dissolved phosphorus. And you can see during the spring melt in the Manning Canal, which is one of our persistent hotspots, the stream is dominated by dissolved phosphorus. And this is kind of what we would have expected to see. The Manning Canal is in the Red River Valley, which is very flat. And so we see water sitting on the land in that flat topography, and it kind of steeps like tea and pulls phosphorus from the soils before running off into our waterways. And so we typically do see high dissolved phosphorus in these areas. So this is in line with what we were expecting. Another interesting way that the network is being used, I guess, so not just the data, but the infrastructure that we've built of this community ready and able to collect water samples. when it's important, is that researchers have been using the network to collect data on other parameters. So we're interested in phosphorus at the Lake Winnipeg Foundation, but this researcher from the University of Manitoba was interested in salinity. And so he added a bottle to each of our sample packs, and then for his PhD got thousands of salinity samples from across southern Manitoba. So that's been a really great partnership, and also I think built a lot of trust between our program and academics, and demonstrating how they could work with the network to study some of the things that they're interested in. I'm just going to finish off by talking about the future a little bit. So right now, the spring melt is kind of happening as we speak in Manitoba. We are obsessively watching the ice melt on the sidewalk and checking the flow online to mobilize volunteers and partners. So I think a few samples have been collected. I think I can say we've launched our 10th field season, which is really exciting. And a part of our field season includes conducting field audits where we go out and visit all the volunteers at their site, as well as a sampling sites newsletter where we share information on the program. Sampling is like quite a solitary activity. Each volunteer has their equipment and has their site nearby, but we want to remind everyone that this is really a collaborative effort. And so we use this newsletter to do volunteer and partner highlights, share examples of how the data is being used. We do photo contests and other engagement opportunities like that. Another thing we are planning as we look ahead is to establish some of our own flow metered stations. So as I mentioned, water survey stations aren't always located exactly where we want them to be. So there's some key stations that we're interested in collecting our own flow data so that we can calculate the loads and exports. And then this year we brought back our annual gathering, which we hadn't had since before COVID. So that was a really exciting time to bring together all the government folks who are interested in our data, the volunteers, the watershed district partners, and the data users all together in a room to present and talk about this important data set and how it can be used to protect Lake Winnipeg. So I'll just end there and again say this is a collaborative effort between the Lake Winnipeg Foundation, Manitoba's watershed district partners, our science advisors, and all of the volunteers who volunteer their time to collect these phosphorus samples. So thanks for having me here today. And of course, I'll be around after Larissa's presentation to answer questions.
Awesome. Thanks so much, Chelsea. It's so interesting to see how your program is evolving and what next steps there might be, and wrote down some notes about like, ooh, what could we be doing next? Also didn't know there was a Miami, Manitoba. So that was a key takeaway for me.
It's a little different from Miami, Florida, but
just a couple
special
small differences. I do want to remind people that if they have questions, to please drop them into the question and answer section at the bottom of your screens. We are going to be answering questions at the end of the webinar, and if si les gens en français sont là, ils veulent poser les questions en français, on peut faire nos plus belles efforts pour répondre à vos questions. So I am going to introduce the Ottawa River Keeper Total Phosphorus Monitoring Program, and then also based on the research that Lake Winnipeg Foundation had been doing, we also put together some nutrient loading reports for the first time this year, as Matthew mentioned, as part of some funding that we had made that was made available to us from the Canada Water Agency, which was really exciting to have the opportunity to do that and learn a little bit more about how the Ottawa River is impacting the St. Lawrence River system. I will just highlight the fact that despite the St. Lawrence River and the Great Lakes water system being one of those priority watersheds that also benefits from the funding that the Lake Winnipeg region benefits from, for some reason, the Ottawa River is not considered part of that funding program. And so we are reliant on these standalone grants, which we're very appreciative of. So, oh, this is where I have to get my thing. There we go. Just a reminder that once again, the Ottawa River watershed is almost the exact same area as the unceded, unsurrendered territory of Algonquin and Anishinaabe Nation, and that while Ottawa Riverkeeper recognizes the legacy of colonialism that continues to have a profound impact on the rights of Algonquin people, and that there is an urgent need for meaningful action that truly confront its legacy. And we work as much as we can in collaboration with Algonquin communities in different parts of the watershed as those opportunities become available. So for those of you who aren't familiar with the Ottawa River watershed, the river itself is just over 1,200 kilometers long. The watershed is about twice the size of the province of New Brunswick. It spans two provinces, Quebec and Ontario. And what makes it unique is the fact that the provincial boundary the Ottawa River forms the provincial boundary for most of its length, from just above the Capillon Dam all the way up to Lake Temiskaming, where it is completely in Quebec. And a quick overview of Ottawa Riverkeeper itself. We are a charity where we consider ourselves to be a watchdog or a guardian for the river, which means that we often work with authorities or ask authorities to be taking more action to ensure that proper protections are in place to protect this watershed. We do work collaboratively and across jurisdictions. And so a key example of that is all of the work that's being done in bringing this data together. There's data on either side of the river, and it really requires reaching out to different groups and organizations to understand how data is collected so that we're able to do this analysis fully. We have a variety of funding sources, and so we remain independent. And our work is really science-based in terms of providing evidence-based information to decision makers. I'm assuming everyone can see my screen, and if they didn't, then someone would jump in and tell me that they're not seeing it. So the reason why we started testing for total phosphorus is that we started a program a few years ago called the Watershed Health Assessment and Monitoring Initiative. This was an initiative that came out of a couple of different reports, which pulled together all of the data available in the watershed, and through our watershed health committee, 14 different indicators were determined to help measure the ecological health of the Ottawa River. This study began by looking at the data, and then we started implementing community-based monitoring programs to help collect data where it wasn't readily available. Data gaps is one of the biggest issues for being able to do any analysis of the health of the Ottawa River. And so those community-based monitoring programs became a key activity for Ottawa Riverkeeper. Not only is it total phosphorus, but we also collect data on invasive species, ice on, ice off, algal blooms, and then we have a program of going out and collecting benthic invertebrate data as well. And all of this data came together to help us write our first watershed report card, which was last year. We broke the 14 indicators into 4 different categories: primary productivity, biodiversity, physical characteristics, and human development. Our watershed report card is available online. It's free to look at. It's available in both French and English, and it provides a bit more information about how we reached those different grades for the different categories. There's also supplementary reports that are available on our open data portal for those who want to dig a bit deeper into some of the issues, such as what we learned about mercury in the Ottawa River watershed. We have a much longer document explaining where that data came from and the findings that went into it. So I encourage everyone to take some time to take a look if you're interested in learning a little bit more. And one of the key pieces of that is in our primary project activities section is where we have the total phosphorus data. And so this is so our total phosphorus program started in 2021. So we're still learning the ropes in many different ways, expanding as the program moves on, and we get more understanding of what's happening in it. As Chelsea mentioned, her program grew over the years. It really is a learning process on how to work with community scientists, what needs there are, where there are hotspots, where there needs to be a bit more investigation. And so between 2021 and 24, we have collected approximately 480 samples from 50 different locations. Here on the map, you can see a number of different stations and the locations. They are mostly located close to the Ottawa River, or like near the mouth of the tributaries to the Ottawa River. But there's an investigation that's going on in some of these tributaries, and so they move upstream to try and better understand what's happening in those smaller sub-watersheds. Here's an example of one of our community scientists sampling on Constance Creek in Constance Bay, Ontario. And in the spring, as Chelsea also, something we've learned from the Lake Winnipeg Foundation is that peak phosphorus loading happens in the spring. And so we have community scientists go out in the spring every 2 weeks to collect a sample, and then throughout the rest of the year, up until October, once a month. They collect a water sample, and it's returned to Ottawa Riverkeeper, typically by mail, and we send those to an external lab to have them analyzed. In general, excess phosphorus was found in areas of the watershed with the highest concentrations of agriculture. The Ottawa River watershed is over 70% forested, and so there's a lot of natural protections in place for maintaining water quality. And yet, where we do have agricultural areas in the southern section of the watershed, we see much higher levels of phosphorus, but also there's this unique clay belt around the top of Lake Timiskaming that also has really high phosphorus levels within it. And those are the two areas that we're going to take a look at. Some of the additional sources of data that we used for the total phosphorus loading reports came from additional sources of information. We didn't rely solely on our community-based monitoring program because we wanted to have a better understanding of the full scope of what was available within the watershed, and those came from the Government of Quebec, Ontario, and also the Federation of Ontario Cottage Associations. And just to answer Chelsea's questions about the watershed districts, I'm unfamiliar of the makeup of the watershed districts, but the Ottawa River watershed has both conservation authorities, regions of Ontario with no conservation authorities because they're not consistently found throughout the watershed. And then on the Quebec side, it's the Organisme de Bassin Versant, which provide a different type of services for the province and for watershed protection. So it's a bit of a mixed bag depending on where you are and what kind of work you're looking at what is available. One of the really big surprises for us when looking at the data was just the variety of data sources, the amount of time they had been available for, and where they were available. And so here you can see that the Ontario government data is available, was available starting in 1965. It's available in quite a few locations throughout the watershed, whereas the Quebec government, it's more closely located in the southern part of the watershed and some in the northern part. This is also because much of the watershed is very sparsely populated. And so it's not just that the data is not being collected from those regions, it's a very underdeveloped part of the watershed. And so there's just not the population base to collect the data. And it's mainly forested. And so the areas where they are collecting data is a good representation of where there's the most land use disruption or change over time. And then the real surprise to us was the volume of community-based monitoring data that was available in the watershed, and that's the blue dots. And that really does take up a big section of different parts of the watershed, especially in areas where there are not conservation authorities, and in areas where data is missing from the Quebec side. Another key piece of collecting data is the fact that you need to have data for a long period of time. And so one of the things we looked at was the number of years data was collected, and found that most data is collected for less than 5 years from a program. Very few programs last for longer than 10, 15 years. And this really highlights the need for consistent long-term data to be able to understand some of those trends that might be happening within a watershed. I'm just going to talk a little bit faster so I get through these slides a little bit quicker. I'm cognizant of the time all of a sudden. We talked about total phosphorus loading and when it's most prevalent. This is the example that we have from Carillon, the main dam at the mouth of near the mouth of the Ottawa River. And then these are the locations that we studied as part of our report. So we picked the most highly impacted sub-watersheds with total phosphorus data. As you can see here, the areas with the red, pink, and orange had the highest values for total phosphorus export. And the other key piece is the blue bars here show phosphorus load. And so phosphorus load was most prevalent from the Gatineau and from the South Nation rivers. Du Nord, which actually has the outflow below the Carillon Dam, was one of the next highest ones, with Rouge and Rideau following. So there's some significant total phosphorus loading coming from some of these tributaries. These are the two regions which we're really focused on. So that area in the southern section, and then again around Lake Temiskaming. Oh, did I skip a slide? And one of the things that Chelsea had mentioned was the need to have flow data. And so one of the reasons why this is so important is because sometimes you have a tributary that doesn't have a flow station, but can be contributing quite a bit of phosphorus to a system. And so that's a great example of that is the Wabi River that flows into Lake Temiskaming in the northern part of the watershed. The Blanche River also, we were collecting total phosphorus data from there, but the flow data was upstream from it. And so currently we have an underestimation of the amount of total phosphorus coming from that site. We're going to recalculate that and make sure that and see if we can get a better estimate of those values. But it's a challenge when you don't have those locations matched up quite properly. And when we looked at this data, as you can see, Lake Temiskaming has a large bay around it, and Temiskaming Shores, which is the main municipality on the Ontario side, is located just downstream from the Wabi River. And the watershed for the Wabi River is quite a bit smaller than the Blanche River, but it still contributes 15 tons of phosphorus every year to Lake Temiskaming. Just to remind everyone that 1 ton is 1,000 kilograms. So that's a significant amount of total phosphorus for this lake system. The Blanche River, with our underestimated, is 20 tons per year, but it's likely almost double that once we've recalculated those values. Lake Temiskaming, of course, has had blue-green algal blooms within it, and so it's definitely an area that would benefit from better understanding of where these sources might be coming from and what can be done to try and mitigate those impacts. For the lower part of the watershed near the mouth of the Ottawa, South Nation watershed is the area of the Ottawa River watershed with the highest percentage of agricultural land. And so it's no surprise that South Nation also contributes the most total phosphorus to the Ottawa River. Some of the other ones do, and one of the reasons that is based on the flow. Like the Gatineau has a fairly low concentration of total phosphorus, but because its flow is so much higher, the total loading over time is the next highest in the watershed. And then the biggest takeaway for us through doing this research was understanding the loading that happens from the Ottawa River into the St. Lawrence. And so there's a number of sites that have significant amounts of agricultural activity around the St. Lawrence, further downstream from where the mouth of the Ottawa reaches the St. Lawrence. But the thing that really stood out for us is that despite the fact that the Ottawa River is known as a main tributary and but is not often used in calculating impacts on the St. Lawrence, the Ottawa River contributes almost as much total phosphorus to the St. Lawrence as the St. Lawrence does itself, just at the same confluence. And so right upstream from Montreal at the Beauharnois Dam, the total phosphorus loading is about 1,530 tons per year, whereas the Ottawa is 1,400 tons per year. And so we're just below that is coming from the St. Lawrence itself. And so and they're pretty close together, so they mix really quickly in the same region. And that was our very quick summary of it. I'm wondering if anyone has any questions. I would like to, of course, really thank all of the community scientists who participate in our programs. They are the reason why we're able to put this data together and understand what's happening in the watershed itself. And so I just wanted to do one last big shout out to everyone who participates in our programs, and also for the great collaborative effort that we have in the watershed and from other watershed organizations. So I'm curious to see if there's any questions from the participants, but I do have one for Chelsea, if that's not the case. I'm going to stop sharing so I can see everybody. So Chelsea, you talked about how your data is used by all of these different groups. Oh, I see Jennifer has her hand up. Jennifer, if you can put your question into the Q&A, then we'll be able to access it. I'm not sure if we're able to unmute people to ask questions. So that would be the best way to get your question asked, and we'll repeat it out loud for you. But you mentioned, Chelsea, you mentioned how your data is being used to really help influence what is happening in the Lake Winnipeg watershed and with the research and whatnot. I was wondering what barriers you have had previous to that to getting, like, is this a new phenomenon for the Lake Winnipeg Foundation, that there is interest in the data and how it's used? What did you have to do to get that data sort of appreciated for the high value it brings to understanding the region?
That's a great question. And it feels like it's been many years of baby steps for getting, people comfortable, I think, with the community-based monitoring data. We basically offered to jump through any hoop that people are interested in. So for example, joining that Proficiency Testing Canada program for our lab analysis. We do field audits where we go out and meet the volunteers, make sure they're following the protocols, and we do have field blanks and stuff like that we test as well. And then I think a lot of QA/QC and being really transparent about the data that we're collecting and the uncertainties, as well as the things that we're really confident in. I feel like that transparency, making corrections when they're needed really quickly, that can build a lot of trust. But I think it's just been over time and just continuing to show up and present our data in new ways, and finding the leaders in the research communities and the government communities who are interested in the data and see the value in it, then they can kind of spread the message within their own communities. That's been really helpful as well. And I think I was just saying to the executive director, like, I think this year I feel like a lot of momentum in our program. Like there's lots of researchers interested in the data. There's the government is like much more curious about it and wanting to use it in different ways. So I'm hoping that we've
it is one of those things that I feel like we also have to do, is just constantly advocate of how community scientists are typically really great at collecting data, and that there's a number of protocols that we follow as well to ensure that that's the case. We do have a question from one of the participants, which I'll answer, about how to ensure that the samples are properly preserved and stored when sampled by citizen scientists. And for our sampling program, there is a bit of preservative that's added to the bottles before a sample is retrieved. And so that acid that's included in a very, very small amount helps the sample be preserved for, I believe it's 21 days, it might be 28. And so this is really critical for our sampling program because samples need to get mailed back to us. And that helps with that transportation. We could not do this program if a preservative was not added to the bottles, because there's just no way we can collect data from the Lake Temiskaming area and have it delivered in a short period of time. It also helps to manage the cost of shipping when a sample can have a longer hold time, so that a couple of samples can be collected and sent at the same time. But we definitely we looked into that before determining it, and that was a value that was provided by the lab. And so there's a high confidence in that piece. I don't know if you have a preservative in your samples as well, Chelsea?
Yeah, we have a diluted sulfuric acid
Yeah.
in the bottles that go out, and then that prevents the phosphorus and the particulate matter from sticking to the sides.
Exactly. Yeah.
Also is key to the program functioning.
Yeah. You can't really expect people who are volunteering their time to take a sample and then, drive X number of hours to get it to the place. So, and so I'm just quickly looking at some of the other questions. There is one from one of the first ones we got about types of septic systems, as well as weeping tiles that is found in agricultural areas. So for the work that we're doing, we don't sample directly next to a specific site. It's more within one of the streams themselves. So the tributaries, the samples are taken from the center of the stream, typically from a bridge, where there is the flow is moving. This is to help reduce the chances of additional sediment particles getting into the samples or disturbing the beds and accidentally elevating it. So we encourage our community scientists, and we find locations that are above bridges so that they can sample off of the bridge. There is, I'm sure, research out there that has looked more specifically at weeping tiles in terms of how much phosphorus is being contributed, because they are designed to remove water from a field so that farmers can start working on them faster. I'm sure they have an impact on the amount of total phosphorus that's being introduced, but we just haven't looked at that specifically as part of our program. And similarly with septic systems, that needs to be done at the municipal level. And I know of some regions of the watershed where they're doing surveys of the septic systems to see if they're functioning properly. I hope that answers your question. And if not, you can always follow up by email.
So there's a question from Paul about whether a buffer of natural plants along a river reduces phosphorus runoff from agriculture. And if it does help, how wide a buffer of plants is best. And either one of you could jump in on that question.
Has there been some good work done in the Lake Winnipeg area, like Winnipeg watershed on buffers for agricultural areas?
Yeah, it's been quite an interesting area of study in the Lake Winnipeg watershed, especially in the Red and Assiniboine rivers. So that's a beneficial management practice that we've kind of took from warmer climates and imported here to Manitoba. And once it was studied, we realized that they weren't working very well to reduce phosphorus loading. So one of the challenges is that most of our phosphorus load and runoff happens during the snowmelt period when the ground is frozen. And so those buffers aren't actually like functioning. They're not, they don't have the ground's frozen, so the roots and the plants aren't taking up phosphorus from the water as it's running off. And then another thing that was found, because the idea was that these as climate change continues and the snow melt may not be eventually the key contributor of phosphorus, that these buffer strips may become even more important at reducing phosphorus. But I think from the research that was conducted in Manitoba, what they found was the water would find these, what they called in the paper, preferential flow pathways. So even if there was a very thick buffer, the water would kind of all come together and create this little mini river going into the ditch that ended up kind of bypassing the buffer strip, unfortunately. So it hasn't been the kind of solution that we were hoping it would be in our watershed, at least.
Yeah, and I think I mean every watershed has its different characteristics that will shape it, and buffer systems can reduce the total phosphorus if they have like even just having some texture to where the water flows could help. So even in those preferential areas, there's probably some of the sediment that would erode that's getting trapped in some of those areas, but it's never as simple as one particular thing, and definitely probably it has a lot to do with the makeup of the soil and whatnot, because there's evidence that it has been successful in other areas, but every watershed is going to have different characteristics of how that looks like. And that also there's different parts of the country where even just having different plow management, so the way that the farms, the fields are plowed, can really impact the amount of runoff. And so by reducing the runoff, you can help manage it. But spring is a really hard time of year because everything is frozen and nothing is getting pulled up. And so the theory of a buffer really requires those root systems to be working, right? So it's a challenge of how nature actually works, and it can be a challenging space when it's all frozen. I'm noticing the time, Matthew. Do we have time for one more, or should we?
I was gonna say we're running a bit over time. Why don't we do one final question? I do see this one that I think is pretty interesting, and I'd like to know the answer if there is one from an anonymous participant, which is, has the collection of this data led to the identification of any sources of phosphorus that are not either agricultural or sewage based?
Is that a question for me?
It's a question for both of you.
Answer first if you'd like.
I would say that that's like a big piece of information that's missing from our project. So where, like I said, like we know kind of what these hotspots are, but there's still really big areas that have often both agricultural and sewage sources and other potential sources of phosphorus. One thing that is going to be a part of that spatial analysis study is looking at the long-term data from some of these sites from the province, because some people think that these hotspot areas might just be areas that have always contributed really high amounts of phosphorus. So we'll be looking at things like that as well. Based off of the data I've seen, I'm not expecting that to be the case, but yeah, we could find out something really interesting from the land use data that we were not expecting. And that's why I'm really like curious about what we're going to find through that study.
That's great. And I'll just add that because of the number of sampling sites that we have and where they're located, those are within the stream. And so we've usually contributed it to the land use data that's available. That's not always correlated with the land cover. So there might be the way that it's been classified might not always reflect how the land is actually being used. But I would say that total phosphorus is known to be largely contributed from urban areas as well as agricultural areas. And so with the combined sewer overflows that can happen after a heavy rainfall event, that can be a huge contribution of total phosphorus. It's harder to catch because it's not that, it doesn't add in the same way to the average flow, but it would have an input of phosphorus all at once. And stormwater can be a large contributor to total phosphorus in urban areas, even if it's not a combined sewer overflow. Having waste and fertilizers from gardens that are running off into storm sewers can really also add a pulse of total phosphorus from those areas. And so wastewater treatment facilities are known to be a source of total phosphorus pollution. In the work that we did for this study, they weren't included because those sites aren't located around the Carillon Dam. They would be within the Ottawa River itself, but if they are contributing for a long-term distribution, they would have been captured at that total phosphorus measuring station at Carillon Dam. So that's a quick overview of how we understand it. And always there's more work that can be done and there's more analysis that can be happening. Right now, the work that we're doing is similar to Chelsea's work, trying to identify some of those hotspots. And then hopefully that data can be picked up by local organizations like conservation authorities who work in those areas, or we will work with different levels of government to try and see what work can be done to help bring those total phosphorus numbers down. But a huge thank you to Chelsea for joining us today. It's really great to get a chance to swap stories about total phosphorus monitoring programs. And thank you everyone who joined us today and who stuck around to the end. Always great to get the questions from folks who are participating in these activities.
Thanks everyone. Bye.